So when we use cosine law, it's whenever we can't use sine law in an oblique triangle. Specifically, there's two cases where we use cosine law. Usually it's side, angle, side with the angle in between the two known sides, and that's all you know. Or you know all three sides but no angles. With sine law, you need to know at least one side length and one corresponding angle, so the angle opposite of the side. So if you know angle A, you need to know side length A. And you would at least need to know at least one other angle or one other side length. There's a few different things that were given in cosine law. I'm going to show you the first two equations here. In these two equations, they're a little bit less common, but notice how whenever we start with a squared, like right here, a squared, we end with cos A. If we start with b squared here, we end with cos B. So if b is here, it ends here. The next thing to notice is the two letters b and c. So in the first equation we have b and c. Those will be in here now. We'll have 2bc cos A because we ended with a. In the equation b squared equals a squared plus c squared. So we have a and c. These two letters will be over here now. It's the same formula. We're just changing the letters around. It's also interesting to note that usually when you talk about cosine law, these formulas are pretty uncommon. So I just wanted to note that before that we move on to the final formula. And the final formula that you need, as pointed out with the blue arrow, we have c squared equals a squared plus b squared. Remember from the review lesson, I told you guys Pythagorean theorem can be written as c squared equals a squared plus b squared. It's just Pythagorean theorem, nothing's changed. And if you use the tricks from the last two, you can remember cosine law pretty easily. Because we started with c squared, we end with c. And because we have a and b over here, that means that a and b have to go with the -2. So you're not actually remembering a whole lot this method. All you're doing is Pythagorean theorem. Make sure you end with c, with cos c, because you started with c squared. And make sure you have minus 2ab. So it's a little bit less to remember. It's still a lot to take in. So it might take you a little bit of time to remember that. Moving on to the next example, we have angle A here, corresponding with side length A over here, which is the 8. I'll use green to denote that. For angle B here, so angle B, it'll correspond to this angle over here, or this side length over here. And it's side length 11, which is just side length B. And then in blue, we have angle C here, which corresponds to the side length C. And we're already given the angle for C. So this is the first example. Usually, for cosine law, there's only two cases, side, angle, side. We're given a side, so side B, and side A, where it's 11 and 8 respectively. And then the angle in between, which is 37 degrees. So to solve for this, I'm actually going to use the last formula there. The last formula uses c squared equals a squared plus b squared minus 2ab cos of c. And then we're going to start subbing stuff in. So then we'll end up with c squared equals 8 squared, because that's what a is, it's 8, plus, and then our b squared, so our b is 11, minus 2, and then we sub in our values. I'm going to put them in brackets just to avoid confusion. 8, and then 11, and then cos, and then our c value, capital C is always the angle, 737. Once you are at this point, I highly, highly recommend you use your calculator to solve this to the best of your ability. Remember that with your calculator, you might have to do cos 37 first and then multiply. If you do this in multiple steps, you're going to get rounding errors because calculators can only go to so many digits. and every calculator is a little bit different, which makes this really tricky to solve. So when you have 8 squared plus 11 squared, then subtract, it might have to be cos 37 times 11 times 8 times 2. Depending on your calculator, is going to be different. So when you calculate this, which I'm going to give you a chance to try, enter what you get. 4401 approximately. Now, the problem with this is I've written out some steps. There's more decimals involved, and we still need to take the square root of both sides to get what c is equal to. This is why I want you to just do this in your calculator and then do the square root of your answer at the end. Most calculators will let you do this. We've practiced this. So now you take the square root and you should get c equals about 0.67. Now we're not given units for the length, so it's 6.67 is the approximate side length. For our next example, I have solved for angle C. So for our next example, we have solved for angle C. You set it up the exact same way. Because we're looking for angle C, we need to have a formula that has cos C. Notice how we have C here that's unknown, and it says solve for angle C up here. That means we want cos C. So of the three formulas, if we go back a page, there's only one that has cos C in it, and that's the third one. I find it easier to memorize the third one and then work my way backwards and rewrite the letters as I need. But I would definitely memorize at least the third formula for this. I would write it out again and again. So in this case, we're going to use the third formula, which means I'm going to have c squared equals a squared plus b squared minus 2ab, because a and b were already given, and then cos of angle C. Because I started with C, I have to end with C, even though one's a side length, one's an angle. All right, and now I start subbing stuff in. I'm actually just going to reveal for this because it's a bit neater than my writing. And when we sub stuff in, we have now a side length for side C. And then we have 5 for B. These two got mixed up, but that's okay. It doesn't change the math. The math still works. And then we have B, which is 9, which if we look at our diagram, this is actually flipped. Regardless, if A and B get switched, that's okay, as long as C is in the right spot. Notice how C is side length 8. As long as that's in the right spot, your math is going to work out wonderfully. Then we have minus 2. This would be AB, but this is just BA, and because 5 times 9 is equal to 9 times 5, it doesn't matter the order again. So now we really see that it doesn't actually matter. We end up with cos C over here. So what we're going to do is we're going to calculate all this out as much as we can, and you're stuck with 64 equals 25 plus 81 minus 90 times cos C. We're going to try and isolate the minus 90 cos C, because specifically we want to figure out what C is, but we're not ready yet. So we're going to start moving the terms around. We're going to move the 25 and the 81 over to the 64 and subtract them away from the 64. And we'll end up with minus 42 equals minus 90 cos C. Now to get rid of the negative cos, or the negative 90 that's being multiplied by our cos C, we're going to divide both sides by negative 90. And we end up with this decimal here. If you can use a fraction, I would recommend using a fraction. It'd just be negative 42 over negative 90, which becomes a positive. And to get rid of the cos next to the C, we have to do the opposite to both sides. So at this step here, we're going to take the cos inverse of this decimal, which equals cos inverse of cos C, because remember, when we do the cos inverse of cos, it cancels itself out. So now it's just cos inverse of this decimal is equal to C. And now we can solve for c. If you use your calculator, you should get c equals about 62.2 degrees. And those are the two cases for cosine law. Earlier we saw a side angle side. This is just side, side, side. Moving on to our final example here. It says solve triangle XYZ. Here we might want to be a little bit careful because we don't have a triangle with A, B, and C labeled. If you're considering the formula, I'm going to write it up here. C squared equals A squared plus B squared minus 2AB cos of C. Because we're going to try and find this side length here, we're going to rewrite these letters where we need them. Notice that we're trying to find Z, and it's a side length. That means we're going to have Z over on this side because we're trying to find that side length. That means Z squared equals, well, X squared plus Y squared minus 2XY, because X squared and Y squared were on the right side of our Pythagorean theorem that we wrote out earlier. And then cos of Z, capital Z, because it's an angle, not lowercase. Don't get them confused. We're trying to find the lowercase z. So now that we have this formula, we can start subbing in all the parts. X is going to be 9.4. Y is going to be 6.5. However, if you mix them up and you put Y where X is and X where Y is, that's not going to matter. Your math is going to work out. The one thing that you should really note, though, is because we're trying to find Z here, like I highlighted earlier, Z is very important where you place it. The other two, not so much. So when you sub in everything, we see that X squared is where Y is, and Y squared is where X squared is supposed to be. This just highlights that it doesn't actually matter where you put it. The math still works out because 1 plus 2 is still 2 plus 1. So the addition doesn't matter, as well as the multiplication, because 1 times 2 is still the same as 2 times 1. They're communicable. So we sub it in, and then we're going to do our calculation in our calculator to the best of our ability. Give it a try, and you should get Z squared equals something about 210.7804 to 4 decimal places. Whatever number you get in your calculator, just keep it. Usually students skip this step and jump right to what Z is equal to, because once you get your answer, you can square root it. If you can't do that on your calculator, write it out to at least 4 decimal places, round it, and then do your square root. So you should get Z is equal to 14.52 after you take the square root. So now we have a side length. Next is really up to you how you want to go about this. We're actually just going to use sine law. So remember how I said in the review, if you're going to solve a triangle using cosine law, sine law does come up. Well, here it is. We need to use sine law to find an angle. In this case, I actually use sine law to solve for x. You could use sine law to solve for y. Just make sure you have the corresponding side length. When you get to the end, you'll still get the right answers and the math will work out. The only issue is you might confuse what side length y, or what angle y is and what angle x is. You might get them flipped and reversed. Just remember, largest angle will go with the largest side, smallest angle will go with the smallest side. So by that logic, x should be the second largest angle. Okay, so I'm going to solve for x. You could solve for y on your own, and I use sine law. So I set it up. I have sine of z over side length z, and then sine of capital X, because that's the angle, over 9.4. Because we take a look at angle X up in the diagram, 9.4 is what we're using down here in green. So it has to be a corresponding angle and side length. If you wrote 6.5, you'd be actually finding angle Y, and that's why this gets so confusing. If you wrote 6.5 and you're working through and you want to find angle Y this method, you can. At the very end, you should get a very similar answer, but it's It can change depending on rounding errors. That's why marking for trigonometry is a little bit tricky. So you use your cross multiplication, and you should end up with sine of x equals 0.4886, approximately to 4 decimal places, of course. You do not need to write out this step. I never told you guys that you had to. I rarely do this. What I often do is I go straight to the answer, because if you round it, you're going to end up with rounding errors, and it compounds exponentially as things go on. Also, to solve for this, now we just take the sine inverse, just like we took the cos inverse in example 2 of this. So we're just going to take the sine inverse of the decimal that you get on your calculator, and that should give you angle x is equal to 29.2 degrees. Now, to solve for the final angle, you could use sine law. There's nothing wrong with that. But it's a bit of a roundabout way of doing things. You don't have to. There's actually a quicker way. If you recall, all the angles within a triangle add up to 180 degrees. So we can actually just subtract away angle z and angle x to figure out angle y. And that's exactly what I do. And you should end up with angle y equals 19.8. For an extra challenge, I ask if anyone can solve the example 3 without using sine law. There's only two things, or two formulas / methods, if you want to call them methods, but I would say they're formulas, that will work on oblique triangles. So if you can't use sine law, you have to use the other. That's probably too big of a hint, but if you can do that, great. If you can't think of a way to do that, well, you guys can move on to the assignment and then come back to that challenge question if you're finding it too easy. Best of luck with cosine law. Remember, if you have questions, post them in the forum on Brightspace. Hopefully others will answer, and I will definitely check the solutions to make sure you guys are on the right path. We're all in this together, and you guys have a good day.